Hi everyone. So in the last video in this series of Kubernetes, we have learned about replication controller, replica set, and deployments. So now we are going to learn about the services in Kubernetes. What is services in Kubernetes? So so it is like an abstraction that defines the logical sets of pods, and by policy which do we have to access. So this is about the definition basically, but let's go and understand basically what is pod. So what is services? Okay, so as we know that pods are ephemeral in nature, right? So ephemeral means in nature means it can be created and destroyed, right? Destroyed. So and that too it is a dynamically, right? So pods can be created and destroyed dynamically, and and if somebody is there who wanted to access the pod, right? So we don't and if you remember last time we have already seen that when we create a pod, right, it generates a unique IP address for it. Okay, unique IP address for each pod, right? And when it is newly created, what happens is new IP address get created for the pod, right? Now you assume that there is a client who is trying to access a pod on some specific IP address. Okay, let's say it IP1, and after some time the pod got recreated. Okay, and the client is trying to access to that same IP1 IP1 IP address, but pod will what it will do is it will have another IP address IP2. So due to which here the connection was able to meet, or we were able to connect it, or we were able to send the request. Here it was successful, but here what will happen is the request will fail because the IP address got changed, right? So every time client was trying to request the pod, it can change the IP address dynamically. And as we have learned in the previous sessions, deploy what will happen, deployments and all, it will recreate another pod immediately, right, based on the replicas. So due to that, these pods will get a different IP address. So client will keep on failing. Okay, the request will not go. To overcome this challenge, what we have what new service Kubernetes gave us, they have given a service. Okay, so services, services in Kubernetes. Okay, that's the topic came in picture. Okay, so services ensure that the network can be reliably reached to the correct pod, even if the pod dies and recreates. Right? I hope you understand what I'm trying to say. So even if the pod is dying and recreates, services ensures them to services ensures that traffic is reliably reaching to the correct pod every time, right? And how many types of pod services are there? Now since we are touching the services topic, so first one is we are also going to learn is cluster IP. Major, let me write what is the main important. Second one is node port. Third one is load balancer. Okay, then there is fourth one is external name, and the fifth one is headless service. Okay, so these are the main services in Kubernetes, but in general we study about these first three. Okay, so in this today's topic we will discuss about all four five, but we will go on the architectural diagram and understand about these. Okay, so what is cluster IP before I go into the architecture diagram? So what it does is it exposes the service internally inside the cluster. Okay, so every cluster will have one unique cluster IP service, and that will expose the all the services. But basically, it will bring all the connections within inside the pods. It will help to connect between each and every pod. Okay, for the communication inside the cluster only. Please remember, only within the cluster only. Right? What is NodePort? So it exposes the service of a static port to the node IP address. Okay, so that is the benefit of having node port here. So it allows the external traffic to reach to the cluster, right? So if here we have understood, right? Here we cannot, okay, here we cannot create any external traffic. The pods has to connect only internally. But in this case, the pods can connect externally as well from the external traffic. Okay. So what is load balancer here? So load balancer provides the external load. So basically it's kind of same like we have in Azure or AWS, right? So it is going to perform the same role here. It is going to balance the load and it is going to distribute the load, right? So production, mainly production and all workloads to handle those places we will use load balancer. What is external name? Okay. So what it does is it maps the external names, maps the service to the external DNS name instead of any IP address. Okay. So here we were connecting IP. Okay, IP. So external name is it will map it to some certain DNS name instead of an IP or a selector. Okay. What is headless service? Okay, it does not it does not connects with the cluster IP and it directly gets the access to the pod. Okay, so it is going to directly connect to the pod. So and I would say this is a special service, I can say. Generally we do not expose these kind of things, but if you wanted to expose your pod directly, then you can definitely use this approach, right? uh, Now let's go and understand about the next thing. Okay, so before I go and touch the architecture diagram, let me explain you with the example also, right? So what happens is, let's say, let's say in a cluster IP, right? So you are living in some, or you are staying in some apartment where you got some extension, or you got some, let's say, let's take a simple example. You are in office. Okay, you have an office of 7 floors, and from one floor to another floor there is a extension. You have 4-digit extension number is given, right? And you wanted to connect, so you dial those four numbers like 1234 or 0000, and you will be able to connect it to the reception. You will be able to connect to any floor, any person, right? If you have an extension number, right? So internally on your office you will be able to connect with those 4-digit numbers to the telephone. But if somebody is from outside the network, or somebody who is not from the building trying to access or call those 4-digit number, he will not be able to connect to those people, right? He will not be able to connect to the reception or any places, right? So basically what is happening, only internal connections are happening. That is called cluster IP. Okay, now let's understand what is node port with an example. We have already understand, right? So node port, what happens is, you take an example of reception desk with a direct line, right? So you have a public number. From your public phone number, you are calling to the reception. Okay. And there is a receptionist sitting there who will be able to direct you to the correct person. And he will be able to tell you, okay, go and talk to, okay, you wanted to talk to this person. Let me connect you to that person. Okay. Like that, node port will work, right? What is load balancer? Okay. You take an example here of, uh, you're calling at any call center or a service center. Okay, and you called any call center, and you tell like, okay, when you call it, you dial that number, and that request will automatically go to the person whoever is free, right? It will not, somebody will not pick you and route you to the another person. Rather, when you call it, it will directly goes the request, or your phone directly dials to the person whoever is free in the list. Okay, so that is called load balancing situation. Okay, so that is something like load balancer. Now let's say about the external name. So basically in external name, right? So imagine like somebody moves to another country, but you still sends a letter to their old address, right? So the postal service, what postal service will do, it will forward the mails to the new location without you know, right? Without you knowing, So it is going to send all the address and mails, right? So that's how external name work. And in case of headless service, okay, in case of headless service, what happens is, so you suppose you directly, you are sitting in some company, okay, let's say you are on 7th floor, any floor you are sitting, but person from the outside world, right, he will be able to directly call to that person directly, not even trying to reach out to reception or anybody, is directly calling to the person. That is called headless service. Okay, you can call them directly skipping the receptionist. Okay, so headless service is like giving out direct contact number instead of main line, right? That is called headless service. Okay, so I hope these examples I gave is easy to understand and correlate. Now let me explain you about the first service through the architecture diagram as well. So let's say the cluster IP, right? We discussed about the cluster IP. So what we discussed in the cluster IP, that only it will be able to expose the service internally within the cluster. So let's say this is a cluster, right? So you are able to expose the request only inside. So outside, if any request will come, right? So let's say if this request is trying to come here, okay. So so if any request will try to come here, so it will get rejected here itself. Okay. So the request will get failed here itself. Okay. So the request will get failed here. It will not be able to go inside this. Even if you will try to reach out to the client, you will not be able to reach out. Or cluster IP, you will not be able to reach out to the cluster IP. Basically, all the requests will get failed. But you suppose you are trying to access from inside the cluster, and client wanted to talk to this pod or this pod, any pod inside the node. The client will first direct or request the cluster IP address. Based on the cluster IP address, it is going to route it to the correct pod. Okay, so that's what this is called as cluster IP service. Okay, so it is used mainly to connect internally within the cluster. So let's say there is another DB pod or database pod, you will be able to, and client wanted to connect to this. So client will first send a request to cluster IP, and then it will send a request to cluster. So DB basically. Okay, this is another pod. Okay, so like that, it will be able to send the request. Now, second thing is what we have learned about second thing, that is NodePort. In case of NodePort, what happens is, okay, so if anybody wanted to get the access to these pods, right? What will happen is, let's say if there are if there is a client is sending a request, so instead of service IP, there is another service came in picture, that is called NodePort. So what NodePort does is, first it takes the request, okay, and then it's route the request to the cluster IP. Then cluster IP send the request to the different pods. Okay, so that is called NodePort. So what is NodePort here? As I told, it exposes your application on the static port. Okay, and on every node IP address. Okay, so let's say I'll show you the another example. If there are two nodes, so it will take the IP address of both the nodes, and it will start routing it to it. Let me show you in soon. Okay, but before we go ahead, the important thing to note here is, okay, for the node port, when we create a node port, it it has a port range of 30,000 to 32,767. Okay, that's the, and these are all called high range port. Okay, and now behind the scene, what it happening is, when you create a node port send a request to the cluster IP as we see in the picture. Cluster IP send the request to kube proxy. Okay. And kube proxy will send the request to the backend ports. Okay. So that's how the flow goes in NodePort. Okay. So I hope you are able to get this example also. We will we will check everything in a hands-on very soon, but let's understand the architecture first. Okay, now let's understand about the load balancer. So this picture will give you more clarity actually. Okay, about the NodePort as well as load balancer. So let's say you have a client, right? And client is sending a request. Okay, he does not know okay which node is having enough number of machines available for your service to or application to run. Okay, so he will just send a request to the load balancer. Okay, and load balancer, what it will do is it will behind the scene it will create a node port, and node port is going to create a cluster IP. In the previous example also, right, when we create a node port behind the scene it is automatically going to create a cluster IP service. Okay, so that you do not have to create. Okay, when you are creating a node port, automatically cluster IP service will get created, right? Same way, when you create a load balancer, automatically node port and cluster IP service will get created. Okay, now when you are sending a request from your load balancer to node port, what actually happens is node port have all the information of the node IP address. So you see this diagram. So if you see this line here, okay, this is node here. This is one node, this is another node. So in this you see there is one line coming here, and it is sending node is sending its IP address. Node port will get the node's IP from the nodes. Okay, node ports will get the node IP from its node. So node port will always have the information what is the node IP address. Okay, so this node port will have the IP address for node 1. Similarly, there is another node, right? This node IP address is also available with this node port. Okay, so what it is saying here is Kubernetes allocate one node port number per service. Okay, so per cluster or per service there will be only one node port. Okay, but the port is always open on every node IP. How it is open on every node IP? Because node port collects that information, right? So node port is collecting that information of node IP address from here, and it is storing here. Same way it is storing the node IP address here, and it is storing here. Okay, so the port is always open to the node IP address. So node port is always open to the node IP address. So you can send the traffic to any node IP using node port. Okay, so what you have to write is you have to give a node port IP address. Let's say you are giving any 172.168.xyz, any number. I'm just giving a random number, and then you have to give a node port this port number, right? So 172.168.x.x, and then you have to give 31,081. Okay, so this request what will do is it will directly take you to this port. It will not take you to this port, this node, right? Because you are trying to hit on this particular node, whatever the IP address is there. So IP address and then node port. What is the node port? It is 31,081. As we have already seen, right? The node port will always have a high range ports. That means it will have the range from 30,000 to 32,760 range, 67. Okay. So I hope this is clear how node port is getting all the IPs. It is collecting all the information from the nodes. And then what we'll do is node port will send the request to cluster IP address, right? That, hey, I wanted to connect it. And then cluster IP address will connect to again kube proxy. That is, we have seen in the architecture video, right? What is kube proxy? That has the routing information, which node is healthy and all. So that it will take. And cluster IP will help you to connect to any of the pods here, and your application will serve the purpose. right? So what is this? You see, this is a kubeproxy. So kubeproxy opens 31,081 port on the node's IP and ties it to the service cluster IP. That's the same example, whatever we have discussed, right? So load balancer request will come. It will send it to NodePort. NodePort will have all the information or node IP addresses because it keep on communicating with all the nodes present in the cluster. So if there are two nodes, this is one node and this is another second node, it will keep on connecting and it will collect all the information of uh, node IP address and it will store it, right? So if the request is going to any of the node, it will automatically send it to cluster IP and it will communicate to kubeproxy, and kubeproxy will be able to connect you to any of the node IP or the pods inside the nodes. All right. So I hope this I'm able to explain you very thoroughly. So this architecture diagram is very important. Okay. Uh, so please kindly go through this video again, and the next video we will upload and we will learn about how to work with these clusters and what is cluster IP in live. We will see, we will execute in YAML command, we will execute declarative imperative both way. Okay, cluster IP we will learn, then we will learn about a node port, and then we will learn about the load balancer. Okay, so all these videos, I mean all these topics we are going to discuss about in the next upcoming videos. Thank you for attending my sessions, guys, and have a great day. Thank you.